Now, I want to talk about two important things, that is concentrated winding and distributed winding. Reason we will see. Concentrated winding. Concentrated winding. Anyone tell me what does it mean by concentrated winding? It means I have a core like this. Is it nothing but concentrated winding? Yes or not? Is it nothing but a concentrated winding? Just observe closely. Very important. This is the current direction, correct? Yes or not? In other words, simply I wanna take like this. Simply I wanna take like this. How many turns are there? How many turns are there? You tell me. How many turns are there? How many? 3. 3 turns. Okay? 3 turns, na? 1, 2, 3. 1, 2, 3. Look at the board, everybody. Look at the board. Don't miss any point. See, current is entering like this, na? Current is entering like this, correct? Current is entering like this. Look at here. The right side of this portion, current is going into the board. Are you observing my point? Look at here. Observe that. The current is entering into the board this side. Current is entering into this board side. Come on, correct? Concentrate. Which is coming out of the board side, this side, left side. Left side, current is coming out, na? Correct? Tell me, how we will represent anything which is going into the board? How we will represent if anything is going into the board? How we will represent? Cross or dot? Into the board. Into the board. Cross. Very good. It means, can I say right side all are crosses, left side are dots. Can I say that? Can I say that? Now you tell me. Current is flowing like this. Flux is coming like this, correct? Flux is coming like this. Yes or not? According to right hand thumb rule or right hand cork rule. What is that? Current, if it is flowing like this, then the flux will coming like this. Tell me how many turns we have? 3 turns. It means this turn is producing a flux, let us say 5. Tell me, this turn is also producing flux in this direction, na? This turn is also producing flux like this, na? Flux like this, correct? Now you tell me, all these 3 flux lines are in the same phase or different phase? All these flux lines are on the same phase or different phase? Outside you are getting some total, 5 total. 5 total is nothing but sum of this and this and this is nothing but total. Now you tell me, same phase means what is the phase difference between one flux to another flux, one flux to another flux? Tell me what is the phase difference? If same phase means, phase difference is how much? 0. Let us say flux is there means induced EMF will be there. Flux is there means induced EMF will be there definitely. Whenever flux is cuts the conductor, EMF will be induced. Let us say this value I want to give 10 at an angle of 0 degrees. This is also producing 10 at an angle of 0 degrees. This is also producing 10 at an angle of 0 degrees. Therefore, tell me what is the E total induced EMF? Come on, anyone. What is the E total induced EMF? 10 at an angle of 0, 10 at an angle of 0, 10 at an angle of 0. What is the total induced EMF? Batao. Total. Resultant is nothing but what? 30 at an angle of 0. Or I can say 3 into 10 I can say. 3 into 10 I can say. Yes or not? Come on. Here only concentrate. Pura ki pura concept. Now dekho ek bar idhar. Suppose if I remove one turn. You have 3 fluxes or 2 fluxes? Tell me. If I remove one turn, you have 3 fluxes or 2 fluxes? 2. If I remove another turn, how many fluxes are there? If I remove another turn, how many fluxes are there? 1. If I remove whole turns, how many flux is there? If I remove whole turns, then how much flux is there? 0 flux. 0 flux will produce an induced EMF. 0 flux will produce an induced EMF. 0 flux, will it produce an induced EMF? No. Therefore, to produce induced EMF, you require a flux. if you want to require a flux, definitely there should be turns or no turns. Tell me, if you want to require flux, you require turns or no turns? Turns required means MMF required or not required? Turns required means MMF required or not? It means MMF will be there or not? Again we have proven that the source behind for the production of flux is what? The source behind for the production of flux is what? Come on, what? The source is behind MMF only. MMF only. Yes. Resultant is 3 into 10 volts. Chalo. Tell me, this is equivalent to which type of machine? Which type of electrical device it is? Tell me anyone. Concentrated winding. Which one? Chalo. Later I will tell you. Don't think much. I have a circular machines also. Correct? I have a circular machines also. Correct? Here how many coils I have taken? Batao ek bar. Here how many coils I have taken? Here how many coils I have taken? 3 coils. 3 coils na? In the same manner I have taken here. 1, 2, 3, 4, 5, 6. In the same manner, right side cross left side dot na? Similarly I will take right side cross left side dot. Clear? एक बार बताओ. Now you tell me. Flux is moving in which direction? Flux is moving in which direction? Like this. Are you looking at this dotted lines where I am giving that? Are you looking the dotted lines where I am giving that? Yes or not? Yes or not? Now you tell me. Why the flux is now distributed like this? Why here flux is not distributed? Why here flux is not distributed? Here why it is flux distributed? You see here? The angle between these two is nothing but some finite angle. Yes or not? Due to circular. Is there any phase angle or no phase angle? Is there any phase displacement or no phase displacement? Tell me. Come on. If let us assume if this is phi, then how you will write this? Tell me. If this is phi, how you will write this? If this is phi, how you will write this? Phi or phi at an angle of theta? Tell me. If you say this is phi, you will write, very good, Shika. Phi at an angle of theta. Similarly, phi at an angle of 2 theta. Correct? This is theta. Therefore, what is this? Phi at an angle of 2 theta. I hope everybody understand. That is theta. I am writing phi at an angle of theta because here to here phase displacement is theta. Here to here phase displacement is theta. Here to here phase displacement is 2 theta. Look at here now. Here to here phase displacement 0. Here to here phase displacement is 0. Here to here phase displacement is 0. That is why tan at an angle of 0, tan at an angle of 0, tan at an angle of 0. Is it clear? And now you tell me. What is the resultant of that flux? Let us say this is 10 at an angle of 0. This is some 10 at an angle of theta. This is some 10 at an angle of theta. Tell me. You have to add algebraically or vectorially? Tell me. These three are, you will add vectorially or algebraically? Why you are adding vectorially? Why not algebraically? Tell me. Why you are adding vectorially? I have a doubt. Tell me. Why you are adding vectorially? Why not algebraically? Phase displacement is there. Tell me, vectorial addition is more or algebraical addition is more? Come on, quick. Vectorial addition is more or algebraical addition is more? Which one is more? Vectorial or algebraical? Come on, vectorial or algebraical? Batao. Vectorial is more. Are you sure about it? चलो देखते हैं. One question I will give you. 10 at an angle of 0 degrees plus 10 at an angle of 10 degrees. Tell me what is this value. Use calculator. More means magnitude. More means magnitude. 10 at an angle of 0 degrees plus 10 at an angle of 10 degrees. Add those two and tell me resultant. Use your calculator. Tell me in terms of r at an angle of theta. 10. This is 10 degrees, sir. This is a 10 degrees. Look at here. 10. 10 at an angle of 0 plus 10 at an angle of 10 degrees. How much? Now you tell me. Magnitude you got 19.92, right? Magnitude you got 19.92. What about this? What about this? This is 20. Tell me which magnitude is more, algebraical or vectorial? Everybody should respond this. Vectorial addition is more or algebraical addition is more? Vectorial or algebraical? Which addition is more? Now you tell me. If this is 30 volts, then is it equal to 30 or more than that or less than 30? Come on. If this is 30 volts, is it equal to 30 or more than that or less than 30? Come on. I need everyone. Less than 30. So I will say E total is equal to let us say some 24 volts. This is 30 volts. This is 24 volts. Can I say that? 24 volts? How to write this 24? Can I write 0.8 into 30 volts? Can I write like that? 0.8 into 30. Can I write like that? Any doubts? The 24, I want to write 0.8 into 30. Both are correct. Tell me what is this 30? What is that 30? That 30 is nothing but the concentrated winding voltage, na? Concentrated winding voltage, yes or not? Concentrated winding voltage? What is the induced EMF? How you write? N into d phi by dt, na? This induced EMF is nothing but what? N into d phi by dt? Yes or not? N into d phi by dt? N into d phi by dt? N into d phi by dt. It is nothing but 0.8 into n into d phi by dt. Is it correct? 0.8 into n into d phi by dt. Yes. What is the difference between this circular and this concentrated? What is the only difference? Tell me from the conclusions. What is the only difference you have observed? What is the extra term that you have observed? Extra term. Number. Tell me which number is extra here. Which number is extra here? 0.8. Can I say this is into 1? This is into 1, that is 0.8. Now you tell me. Now you tell me. Have you heard about EMF equation E is equal to 4.445 FT kW? kW, winding factor. Winding factor. Now you tell me. For a concentrated winding, what is a winding factor? For concentrated winding, what is a winding factor? For concentrated winding, what is a winding factor? For concentrated winding, what is a winding factor? How much? 1. For distributed winding? Here, how much you got? For distributed winding, you got how much? Less than 1 or more than 1? You tell me one thing. Less than 1 or more than 1? Come on. Less than 1 or more than 1? Winding factor into n into d phi by dt. Winding factor into n into d phi by dt. Why distributed winding will have the winding factor? Why can't you put concentrated winding in that? That is one question, na? Valid question, na? Sir, why we are putting this concentrated winding? Why for this you are putting distributed winding? I want to put concentrated winding. I hope you know about rotating magnetic field. Have you heard about rotating magnetic field? That we will see in induction motor. But right now I am asking, tell me, do you know rotating magnetic field? Rotating magnetic field will produce for distributed winding or concentrated winding? Rotating magnetic field will produce for distributed winding or concentrated winding? Distributed or concentrated? Which one? Distributed only. Within soon I will prove you distributed winding will produce only RMF. Concentrated 0. No RMF. That is the reason why we are using distributed winding. But I have various machines. Transformer, induction machine, DC machine, synchronous machine. 4 machines are there, na? Out of 4 machines, again I am repeating. DC, induction, transformer, synchronous. Out of 4 machines, which machine will have concentrated winding? Which machine will have concentrated winding? Concentrated winding. Tell me. Which machine will have concentrated winding? Yes, absolutely transformer. DC machine, induction machine, transformer, synchronous machine. Distributed winding will be there, but where? But where? In the armature side or rotor side? Tell me. I am asking again. In synchronous machine, distributed winding will be there in the armature. Concentrated winding in the field side, yes or not? Synchronous machine is a single excited system or double excited system? Just I am recalling. I am not asking any question. You already studied. Just I am asking the basics. If you see synchronous machine, your stator is a distributed winding. Your rotor is separately or exciting with a DC source, na? Doubly excited. DC source, na? DC source, will you give concentrated winding or distributed winding? Concentrated winding, because field, na, that is. Similarly, where the field winding is available? In which machine field winding is available? In which machine field winding is available? DC machine or induction machine? Field winding. Field winding. Where it is available? DC machine or induction machine? DC machine. Shunt field, series field, compound field. I hope you heard, right? Therefore, this concentrated winding is there for first one, transformer. First one is what? Transformer. Second one, field winding. For what? First one, synchronous machine. Next one, DC machine. ठीक है? Field winding of DC machine, field winding of synchronous machine. Concentrated. This is a very famous question in interviews. Tell me, concentrated winding is available for which type of machines and where? Directly you can say transformer. Everybody knows that. Not only you, everybody knows. But that concentrated winding is also there for DC machine and synchronous machine also. Where the concentrating available for DC machine and synchronous machine? Come on. Where the concentrated winding is available for DC machine and the synchronous machine? Come on. Where it is available? Field only. Field. ठीक है? What about this distributed? What about this distributed winding? Distributed winding is nothing but induction motor armature, synchronous machine armature, DC machine armature. Yes or not? Tell me. Synchronous machine armature, DC armature, induction machine armature, right? Yes or not? Respond quick. Synchronous machine, induction machine, DC machine, armature only. Synchronous machine, induction machine, DC machine. Armature is the distributed winding. Transformer, DC machine field winding, synchronous machine field winding is the concentrated winding. I hope it is clear, everybody. So, now, what is the advantage of this distributed winding and concentrated winding? That we will see if you go to induction machine, synchronous machine, of course in transformer also. Okay? I hope you have understood completely about distributed and concentrated. Yes or no? If no, tell me, I will answer that. Distributed winding is rotating part. Of course, shabash. Perfect, Shika. Distributed winding means what? Rotating. Please explain again why only in field winding. See, field winding means what? Field winding means what? You are housing the winding on the field pole. Can I say that? Field winding means what? You are housing a winding on a pole. Correct? Pole. That is called field winding. Tell me, field winding you want to distribute or you want to concentrate it? Field winding, you want to distribute or concentrate it? Concentrate. That is why field winding is concentrated. Poles are not linear. Reason? Because of BH curve. I hope you know BH curve, everybody. I hope you know BH curve, right? BH curve is a linear curve or non-linear curve? Shiv Kumar, BH curve is linear curve or non-linear curve? BH curve, non-linear. That is why your magnetic core also non-linear. There is a brilliant concept is there on that transformers. But right now we have not at all started any machine. We are at still basics, completing basics. Then only I will go to machines. Okay? I hope this is clear, everybody. With your permission, shall I go ahead to interlink? Please. Definitely I will explain BH curve, but here it is not the right time. Okay? Shivakumar, here it is not the right time, but sure I will give you that answer. Okay? Have you taken this? First of all, sorry. Have you taken this everything? Chalo. Sir, what is the value of K in ET means what? Sorry, I am not getting ET means. ET means our total voltage, ET. KW, it is not K. KW is called winding factor. E total is equal to KW winding factor. Chalo. Now, just open your first page. Open your first page. Open your first page. Tell me, generator, EMF is induced, right? Generator, EMF is inducing, right? I hope you are understanding what I am saying. First page, open your first page. EMF is generated, correct? For generator, EMF is generated. Because of what? Flux is stationary, conductor is rotating. Or conductor is rotating in a field. Yes or not? Then only EMF will be induced, right? Basically, tell me how many types of EMFs we have? Basically, how many types of EMFs we have? How many types of EMFs we have? No. 3. Wrong assumption. 3 EMFs. First one, statically induced EMF, dynamically induced EMF, and rotational induced EMF. Third one is rotational. Have you heard about rotational induced EMF? Rotational induced EMF. Have you heard about it? Rotational induced EMF. Yes, these will be there. Write down. Classification of induced EMFs. Classification of induced EMFs.